Alright, in this video I'm going to show you how to create arrays in Matlab. In Matlab they're also called matrices, and how to manipulate them and uh, do things like multiply them together. Anyways, so there's many different ways to create arrays in Matlab or matrices, and I can't even possibly show you all the different ways that you can do it, but I'm going to show you some basic ways. So first, let's just say I wanted to create a 3 by let's just say I wanted to create a 3 by 2 matrix. So 3 rows and 2 columns. So I'm just going to call this matrix A, and I can create a matrix by starting it with a square bracket, and then I enter in the values of the first row in my matrix. So say I want it to be 1, and then I comma separate them. So I either put a space in between them or I comma separate them. I'm going to comma separate them just so it's clear. 1, 3, and then so 2 numbers in my first row. Remember I said 3 by 2, so 3 rows, 2 columns. And then you start a new row, or you end a row by putting in a semicolon. So 1, 3, 2, 2 minus 2, this is going to be my second column, and then my second row, sorry, and then my third row I'm just going to put 0, 1. And now when I hit enter, Matlab displays this 2 by 3, 3 by 2 matrix. So I'm always going to say the dimensions row first and then the column dimension. So 3 by 2 means 3 rows, 2 columns. 5 by 4 means 5 rows, 4 columns. So cool. Now you can create matrices by typing them in by hand. Well, what if you want to make a really big matrix, like 1,000 by 1,000 matrix, a square matrix? Well, there are some handy functions. 2 of them are called zeros and ones, and they just create matrices of zeros, a big matrix full of zeros, or a big matrix full of ones. So I could type in A equals ones, and I put in how many rows and columns I want, and it's going to just make a 3 by 3 matrix full of ones. If I wanted it of zeros, I would just type A equals zeros 3. Now what if I don't want it to be square? What if I want it to be like this one that I did at first, which was a 3 by 2? Well, I could do that. Zeros 3 comma 2, this means give me one that's 3 by 2. Now I can do higher dimensional arrays than just 2 dimensions. I could do a 3-dimensional array that has 3 indices. So I could put another comma in here. Let's do a 3 by 3 by 3. 3 rows, 3 columns, and then 3 sets of those 2-dimensional sheets. There we go. Here's the first 3 by 3 matrix, the second 3 by 3 matrix associated with the third index, and the fourth one. Cool. Now, how do I access elements in my array? Let's go back to setting A just equal to this matrix, okay? So I have A is this 3 by 2 matrix, and let's say I wanted to change this element right here, the second row, third column, change that value to a value of positive 5. Well, the way that I can do that is I use the parentheses notation. A, and then inside the parentheses I put the row, and then comma, and then the column. So I want the second row, the second column, and I want to set that equal to 5. If I do that, now we see this has been changed to a value of 5. If I just wanted to add, say, this component and this component together, I could do that by saying, hey, take A 1 comma 1, that's the first row, first column component, plus a third row, second column. And it takes those two values and it adds them together to give me the answer of 2. Now, what happens if I try and access elements that are outside my array bounds? So what I mean is, what if I try and grab something from this matrix, but I say, give me the 4th column, the first element in the 4th column. Well, this doesn't, sorry, the first element in the 4th row. This array doesn't have 4 rows. So if I try and access the 4th row, 1st column, it's going to say, hey, this index with that you gave, this number 4, which is called an index, exceeds the matrix dimensions. Now let's say, okay, let's say you're just given some matrix and you don't know how big it is, and so you're trying to index into it and check its values and you get this error. Well, there's a function in Matlab called size, and it takes a matrix. So if you type in size A, it tells you the number of rows and the number of columns. It's kind of handy. There's also the length function, which you can give it, and it actually just tells you the number of rows. So if you're talking about a one-dimensional vector, so instead of having rows and columns, I could have created some matrix that was, let's say, 5 rows but only 1 column. So this is essentially a one-dimensional. Now if I type in length, it'll tell me the number of components in this one-dimensional array. Alright, so it returns that number 5. So let's say I wanted to loop over an array and access all its values or print all its values out. One thing I could do is I'm going to use a new function. I'm going to set my A array equal to some random numbers, and I want the array size to be 5 by 1. So this just gives me an array whose values are set to random values between 0 and 1. So now if I wanted to print the values of these out using a for loop, I could say for I equals 1 to the length of A, display A I. So what this is going to do is it's going to run through this loop, and I is going to start incrementing from 1 all the way till the length of A, which is the length of A is going to be 5. So 1 to 5, and it's going to display the ith component here each time. So if I do that, hey, look, it just displays those values there. Now that might not seem very useful, and it really isn't very useful in this case, because if I wanted to see the values, I could just type in A without a semicolon and it would tell me what it is. But if then instead of displaying them, I wanted to change them as a function of I, now I could say AI was, instead of just displaying it, equal to maybe something like 1 plus I times 0.2. And now I can see AI, and my value has been changed to increment from 1 to 1.2, 1.4, 1.6, 1.8, 0.0. Cool. So we can use loops and arrays together, which is kind of handy. Now, there's one other way that I want to show you how to create arrays besides using just punching them in using the square brackets and using the zeros and ones function. And this is really handy. So for one-dimensional arrays, say you have a bunch of x values that you want to generate and store in an array. What you can do is you can say x is equal to, use the starting value of the array, so the first value in the array. So say I want some x values that start at 0 and go in steps of, let's say 0.5 to an ending value of 5. Alright, so what this has done is it's created an array. The size of x is 1 row and 11 columns. So that's why it's showing column 1 through 3 here. 0, 0.51, and columns 4 through 6 are 1.52, 2.5, 7 through 9 are 3, 3.54, and columns 10, 11 are 4.5 and 5. Now, it's kind of hard to read it when it's all on a column vector like this. I don't like the way it outputs. So another way that I could define this is what is inside these parentheses gets set to be an array, and I'm putting them in the parentheses, and I'm going to use this apostrophe, which means to transpose it. So instead of being a column vector, instead of being a row vector, a single row with a whole bunch of columns, it's now going to be a column vector with a whole bunch of rows. And it's so much easier to see the values, read these values out, instead of trying to read through all the different columns here. Anyways, now we've got a whole bunch of x values. Now we could do something like evaluate. We could create a function. Function equals we'll call the argument, I'm going to just call it x, and then x squared. Now this, I'm defining a function, so this x is not the same as this x. This function has now been defined over here. This x is a variable x that's defined only for this function. And what I could do now is I could say y is equal to my function at, I could pass in, now I'm passing in this value of x. Let's make this more clear. I'm going to redefine this function, and instead of calling it x, I'm going to call it let's call the variable z, and z squared. Alright, now function evaluated at x are array values. So it's going to yell at me, and this is because I haven't taught you guys about matrix multiplication yet. So in matrix multiplication, you have to have your matrices have to have appropriate dimensions. So if I have a 3 by 2 matrix, 3 rows, 2 columns, the matrix that I'm going to multiply it by better have only 2 columns and as many rows as it wants. And that's because the number of columns and the number of rows of the 2 matrices that you're multiplying together have to be the same in order for the matrix multiplication to work. If you haven't learned about this, I advise you to look up on the web matrix multiplication and refresh yourself. So the reason why I couldn't do this z squared, so it took my array x, this is my array x, and this array x is 11 columns and 11 rows and 1 column, and it said, okay, try taking x times x, which is the same as x squared. But that doesn't work because it says inner matrix dimensions must agree, because if I take an 11 rows by 1 column, and I try and multiply it by 11 rows by 1 column, this is the number of columns and this is the number of rows, and they don't match. They need to match if you're going to do matrix multiplication. That's what it means, inner matrix dimensions must agree. So what I can do is, if I remember, you can transpose things. So if I wanted to do the dot product between x, so x, and then dot product it with itself, x times x, like this, that would be the dot product. But what you actually have to do is make this transpose. So then it becomes, ooh, a matrix. I should have done it the other way around. That was the outer product. This is the inner product. Yes, I meant CLC, thank you. Alright, so what I did was, when I do x transpose times x, it returns one number, and that's because I'm doing an 11 by 1 matrix times a 1 by 11 matrix. Now these inner dimensions agree, and oh, actually it's not like that. Sorry, because I transposed the first one, so it's 1 by 11 times 11 by 1. And now these outer dimensions become the dimensions of the resulting matrix, which this is just a scalar, right? That's why when I did it before, when I transposed the second one, instead of transposing the first one, if I kept the first one to be 11 by 1, and then did this 1 by 11, 1 by 11, the resulting matrix is going to be, it's going to have a size of 11 by 11. That's why we saw when I did x times x transpose like this, it resulted in an 11 by 11 matrix. There we go, 11 by 11 matrix. Alright, so when you just use x times x, it's doing matrix multiplication with arrays or matrices. So the dimensions have to match. However, what if I just want to take x and I want to square every single value? So I want 0 squared, 0.5 squared, 1 squared, 1.5 squared. So if I want to do that like I would in this function definition, function equals at z squared, well, this is going to take z times z, and if whatever we pass in is an array, it's going to try and do matrix multiplication. But if we put this dot in front, this means don't do matrix multiplication, do element-wise multiplication. So that means take the first component of x and multiply it by the first component of x to get the resulting component of the resulting matrix. So now if I do function of x, it returns an array the same size as x, and now all the components are squared. So I can do the same thing by saying x dot times x. Okay? So hopefully this is clear and it makes sense. It's important that you understand this dot operator and what it does. So you can also do it with the division operator. So you can't typically, what does it mean when you divide two arrays? Oh man, I forgot. MATLAB's got an overloaded operator. Be careful using the divide operator, backslash operator in MATLAB. It's very tricksy. It just gave me a matrix. I'm not going to explain how. That's a topic for another video. But I could do x dot divide x, and this would just do element-wise. So 0 divided by 0 is not a number. That's what this stands for. NaN is not a number. And then all the other values were non-zero, and so any value divided by itself gets set equal to 1. So that's that. Okay, I think I've covered I just showed you how to create an array. So x equals start value, step size, end value, so minus pi in steps of pi divided by 12 to pi is going to give me an X array, and it's going to be a row vector, a row array, meaning one row with lots of columns, which I don't like, so I'm going to make this. Can I just do this? Nope, that didn't work. I can make it a column vector like this, and transposing it. No, it's a column vector. Alright, you get the idea. There's another function called linspace, where if you give it the start value, so I can do the same thing, minus pi, the end value pi, and then you give it the number of points instead of the spacing. So I could say I want 5 points, 5 elements in this array. Oh man, it also defaults to row vector, which I don't like. So I could do this and transpose it to make it a column vector. Alright, lastly, I'm just going to create a two-dimensional array. I'm going to show you how to access entire columns and entire rows. So if I create a two-dimensional array, let's just do A equals rand 3 by 2 again, a 3 by 2 matrix here, the values. I can use the colon operator to access entire rows or columns. So I could say A colon, that means give me every single row and only from the first column. So what that's going to do, it's going to grab this entire column. So you see it grabbed this and it printed that out. That's what A colon first column is. Every row in the first column. So I can actually, I could do this and I could set this equal to some other array. 1, 2, 3. Now I've changed the entire column of A. Now if I wanted the whole row, I just do the exact opposite. Instead of having the colon in the row spot, I pick a row. Let's take the second row. Let's take every column and let's just print it out. Okay, that's this row right here. It selected this row. So now if I do A 2, so second row, every single column, set that equal to -1, comma 1. Now it's going to change these values in the second row. Alright. I think if you just do this, yeah, it grabs every single component, so it's give me everything, but it returns it as just an array. So if I set B equal to A like this, now type in the size of B, and you see B is a 6 by 1 instead of a 3 by 2. Alright, so that's an introduction to arrays, and there's all kinds of cool things you can do with arrays. Maybe I'll show an integration example in another video. So until then, top for now.